Good morning, students. We will continue the topic nutrition, competition number 8.2, and today's topic is importance of lipids in the diet. In our diet, two types of lipids are present: visible and non-visible fats. Visible fat means it is present in the form of ghee, oil, butter, etc. The intake of such type of fat should not be more than 20 grams per day. Non-visible fat means the fat which we cannot see. They are found in cereals, egg, meat, fish, nut, oil, seeds, etc. Now, dietary lipids. These contain fatty acids, triacylglycerol, also called as neutral fat, cholesterol, phospholipids, and fat-soluble vitamins. Fatty acids may be various types like saturated fatty acids, polyunsaturated fatty acids, essential fatty acids, omega-3 and omega-6 fatty acids, trans fatty acids, and palmitic acid. Now we will study in detail one by one. Fatty acids, all of us know, can be defined as hydrocarbon chain with carboxylic acid group. Here carboxylic acid group is the functional group. Fatty acids can be named in different ways. If we start numbering the carbon atoms of the fatty acid from carboxyl end, then we have to number them as 1, 2, 3, 4, 5, 6. Or if we want to number the carbon atom, label the carbon atom as alpha, beta, gamma, then we have to leave the carbon of carboxyl group. The alpha carbon is that carbon which is adjacent to the carboxyl group. Then we have to name beta carbon, beyond that gamma, delta, epsilon, like that. One more way of naming fatty acid is by omega. Now this omega nomenclature is reverse of above two nomenclature. Here we are naming the carbon atoms of the fatty acid as omega 1, omega 2, omega 3 from the methyl end. Depending upon the nature of hydrocarbon chain in the fatty acid, there are two types of fatty acids: saturated fatty acids, which does not possess any double bond in the hydrocarbon chain. Example, palmitic acid with 16 carbon and stearic acid with 18 carbon. Unsaturated fatty acids, they possess one or more double bonds in the hydrocarbon chain. These unsaturated fatty acids are of two types depending upon the number of double bonds present in them. Monounsaturated fatty acid with one double bond, example oleic acid, and which have one double bond and 18 carbon. Polyunsaturated fatty acids means the fatty acids which have more than one double bonds. Example, linoleic acid, 18 carbon, 2 double bonds. Linolenic acid, 18 carbon, 3 double bonds. Arachidonic acid, 20 carbon with 4 double bonds. Intake of polyunsaturated fatty acid decreases the cholesterol level. These polyunsaturated fatty acids are present in all plant oils except coconut oil, and they are also found in fish. Excess of polyunsaturated fatty acid is also harmful for the body because they lead to formation of free radicals. Therefore, it is advised not to take more than 30% of polyunsaturated fatty acid out of total fat intake. This is because polyunsaturated fatty acids undergoes peroxidation at the double bonds. The cell membrane which contain polyunsaturated fatty acid more, then chances of the damage of such cell membrane by free radicals are more, and that process is called as peroxidation. Increase in polyunsaturated fatty acid level is seen in Zellweger's syndrome. Now, polyunsaturated fatty acid in phospholipids. See, on the left side, lower side, I have shown the phospholipid molecule, which is having glycerol. At first carbon atom, fatty acid is there. At second carbon atom, polyunsaturated fatty acid is present. At third carbon atom, phosphoric acid is there, and to this nitrogen base is attached. So this is the complete structure of phospholipid. If you see this in the phospholipid, usually at the second carbon atom, polyunsaturated fatty acid present. Now, when this polyunsaturated fatty acid is present in the phospholipid, this polyunsaturated fatty acid have double bond in cis configuration. Therefore, if you see the structure of phospholipid, the tail of phospholipid is not straight. Therefore, such type of phospholipids, when present in the cell membrane, they will not fit in the cell membrane properly, or you can say due to the presence of polyunsaturated fatty acid in a phospholipid molecule, the tail becomes wide, and due to this, two phospholipid molecule, adjacent phospholipid molecules, will go away from each other, and this is important for maintenance of fluidity of cell membrane. If the tail of that phospholipid molecule is straight, then what will happen? The two phospholipid molecules will tightly present in the cell membrane, and the fluidity of cell membrane will be lost. So this is the importance of polyunsaturated fatty acid. Polyunsaturated fatty acid may be essential fatty acids, arachidonic acid, and docosahexaenoic acid. First is essential fatty acids. The fatty acids which are not synthesized in the body but required for the body are called as essential fatty acids. Examples: linoleic acid, 18 carbon with 2 double bonds. It is a omega 6 type of fatty acid. The position of 2 double bond is at 9th and 12th carbon. Next is linolenic acid with 18 carbon and 3 double bonds. It is a omega 3 type of fatty acid, and the position of double bond is 9, 12 and 15 carbons. Arachidonic acid is synthesized from linolenic acid in small quantity. Therefore, arachidonic acid is always required in our diet because it is not completely synthesized in the body. Now, sources of essential fatty acid. Linoleic acid is found in corn oil, cottonseed oil, egg yolk, peanut oil and soybean oil. Linolenic acid is present in linseed oil, soybean oil, cod liver oil, fish viscera, etc. Now, importance of essential fatty acids. They form structural elements of cell membrane. Just I have shown you essential fatty acids or polyunsaturated fatty acids. Linolenic and linoleic, they are essential fatty acids as well as polyunsaturated fatty acids. They are mainly present in the phospholipid, and that phospholipid, when present in the cell membrane, it increases the fluidity of the cell membrane. Essential fatty acids also plays an important role in reproduction. They are found in testes and ovary and plays an important role in spermatogenesis and oogenesis. Essential fatty acid binds with the free cholesterol in the body to form cholesterol esters, and such cholesterol esters are then excreted out of body through the bile. Therefore, essential fatty acid decreases serum cholesterol level. Essential fatty acid act as a lipotropic factors. Lipotropic factors means these are the compounds which prevent deposition of fat in the liver. If there is excessive deposition of fat in the liver, then it leads to fatty liver. So, lipotropic factor prevents fatty liver. Essential fatty acid also present in the mitochondrial membrane. Essential fatty acids are found to be very important for optimal vision of a person. Now, essential fatty acids are integral part of mitochondrial membrane, just we have seen. Deficiency of essential fatty acid leads to decreased efficiency of biological oxidation. Deficiency of essential fatty acid leads to phrenoderma or toad skin, which is characterized by scaly dermatitis on posterior and lateral part of limbs and buttocks. After completing essential fatty acids, we will see omega-3 and omega-6 fatty acids. Examples already we have studied, but what is meant by omega-3 and omega-6 fatty acids? They are also polyunsaturated fatty acid which contain double bonds at 3rd and 6th position from omega end of fatty acid. If you see, first is omega-3 fatty acid, where the first double bond is present between omega-3 and omega-4 carbon. Now such fatty acids are called as omega-3 fatty acids. The examples of omega-3 fatty acids are linolenic acid, docosahexaenoic acid, eicosapentaenoic acid. Then omega-6 fatty acid means the fatty acids, when we go from methyl end, the first double bond is present between omega-6 and omega-7 carbon. So such fatty acids are called as omega-6 fatty acids. Example, linoleic acid and arachidonic acid. Omega-3 and omega-6 fatty acid decreases cholesterol level and triglycerol level. They also decreases the tendency of platelet aggregation and they prevent thrombosis. Just by increasing the diameter of blood vessel, they reduces blood pressure. They reduces the risk of coronary heart disease. Therefore, these fatty acids like docosahexaenoic acid, eicosapentaenoic acid can be given to the patient as a supplementation who are having risk of coronary heart disease. Omega-3 fatty acid promotes brain development in infants, and hence docosahexaenoic acid can be given as a supplementation to the children. Arachidonic acid can be synthesized if dietary supply of linolenic acid is sufficient. Now, prostaglandin, thromboxane and leukotrienes, these are very important chemicals in the body, are synthesized from arachidonic acid. Arachidonic acid forms 10 to 15% of fatty acid present in the cell membrane. Docosahexaenoic acid is also synthesized from linolenic acid in small quantity. It is present in high concentration in fish oil. It is in our body. Docosahexaenoic acid is found in high concentration in retina, cerebral cortex and sperms. In the deficiency of docosahexaenoic acid, the patient suffers from retinitis pigmentosa. Next is saturated fatty acid. Fatty acids which have no double bond are called as saturated fatty acid. Intake of such fatty acid increases the cholesterol level and they are atherogenic. That means they increases the stickiness among the platelets. Therefore, platelet forms a clot and at the same time they increases the cholesterol level. So both these factors helps in the formation of atherosclerotic plaque, and hence they are called as atherogenic. Saturated fatty acids are found in all animal foods except fish, and they are also found in coconut oil. Examples of saturated fatty acids are trans fatty acids and palmitic acid. Now, hydrogenation. Hydrogenation means nothing but it is addition of hydrogen atoms in the unsaturated fatty acids, so that unsaturated fatty acids can be converted into saturated fatty acids. Here I have given the example linolenic acid, which has 3 double bonds. On addition of 2 hydrogen bonds, 2 double bonds are saturated, one double bond is saturated, and linoleic acid with 2 double bonds are formed. When 2 hydrogen atoms are added to linoleic acid, 1 more double bond is saturated and it forms oleic acid, which is a monounsaturated fatty acid, means it has only 1 double bond. When 2 hydrogen atoms are added to oleic acid, it forms stearic acid, which is a saturated fatty acid. So all linoleic acid, linoleic acid, oleic acid and stearic acid are having 18 carbons, and they are named differently because they are having different number of double bonds. So hydrogenation of oils can lead to solidification and saturation, example of which is vanaspati. Now if you understood hydrogenation, then you can understood these trans fatty acids. Trans fatty acids are produced by hydrogenation of cheap vegetable oils. Vegetable oils are generally polyunsaturated fatty acids. These vegetable oils have short shelf life and they have some peculiar smell. Now if you want to increase the shelf life of that vegetable oil, then the double bonds which are present in that vegetable oil should be saturated by adding hydrogen, and also after hydrogenation the peculiar smell of that vegetable oil disappears. So generally trans fatty acids are used in food industry as they have more shelf life of their foods and they don't have any bad smell, and these trans fatty acids are produced by hydrogenation of cheap vegetable oils. Now where do you find this trans fatty acid in the diet? They are found in dairy products, fast foods, bakery products and processed foods. All these foods cannot be consumed after their preparation, therefore they should be stored, and if polyunsaturated fatty acids are present, then I have told you polyunsaturated fatty acids break at the double bond, giving rise to bad smell to the food. Therefore in food industries, instead of polyunsaturated fatty acid, they use trans fatty acids which does not have double bond. Now what are the harmful effects of trans fatty acids? They are injurious to the health. They compete with essential fatty acids for absorption and leads to deficiency of essential fatty acids. When trans fatty acids are consumed in large quantity, they get incorporated in the phospholipid molecule of cell membrane. As the trans fatty acids are saturated fatty acid, their tail is straight and they can compactly fit into the cell membrane. Therefore, fluidity of cell membrane is decreased, which affect various transport mechanism across the cell membrane. Trans fatty acid have multiple risk factors of cardiovascular disease, atherosclerosis, diabetes. They do this by increasing the plasma lipids level and increasing the LDL lipoprotein, which is also called as bad cholesterol. Trans fatty acid decreases the HDL lipoprotein, which is good cholesterol. Trans fatty acid leads to systemic inflammation, that is swelling all over the body from inside. They leads to endothelial dysfunction. These endothelium are present on the capillaries. So when this endothelium is damaged, then the formation of clot is early. Trans fatty acid also leads to insulin resistance and obesity. Now last fatty acid is palmitic acid. It is the main fatty acid synthesized by the body. It is the fatty acid which is stored in the adipose tissue in the form of triglyceride. It is the fatty acid which undergoes oxidation in fasting state to provide energy. So this is the structure of triglycerides, where central glycerol molecule and to which 3 palmitic acids are attached. So palmitic acid are stored in the body in the form of trialkyl glycerol. Now next fat is trialkyl glycerol. It is also called as neutral fat. Short form is triglycerides. They are esters of trihydric alcohol glycerol with 3 fatty acids. So this is the structure. Now if the fatty acids present in the trialkyl glycerol are same, here it is shown palmitic acid, palmitic acid, palmitic acid, then it is called as simple trialkyl glycerol. If the fatty acids are different, for example it is shown on the right side, palmitic acid, linolenic acid and palmitic acid, so it is called as mixed trialkyl glycerol. Trialkyl glycerol is the main fat of our fat present in our food. It is mainly stored in adipose tissue of our body. It provides energy to the body in fasting and starvation. It provides 1 gram of trialkyl glycerol or fat provides 9 calories of energy. It is synthesized in the body also from excess of carbohydrate consumption. So flow chart is given here. Glucose forms acetyl CoA and this acetyl CoA get converted into fatty acid. Another molecule of glucose is converted into glyceraldehyde 3-phosphate, which get converted into dihydroxyacetone phosphate, and then it is converted to glycerol 3-phosphate. This glycerol 3-phosphate plus 3 fatty acids combines to form trialkyl glycerol. In a normal 70 kg person, 11 kilogram of triglyceride is stored, and that will provide 1 lakh calories for that person during starvation or fasting. Now, if you want to save the same calories other than fat, for example in glycogen form, then we have to store about 65 kg of glycogen to provide 1 lakh calories of energy. This is because glycogen is stored in hydrated form, because carbohydrates are hydrophilic, whereas fats are hydrophobic. Therefore, when trialkyl glycerols are stored, water molecules are repelled and space required for storage of this trialkyl glycerol is minimal. So this is the comparison between stored carbohydrate and stored fats. Sometimes in give reason they may ask why fats are preferred as a storage material, storage energy source for our body. So this is the difference between triacylglycerol and carbohydrate. Now these triacylglycerols in our food, it is present in two forms: oils and fats. Oils, they are liquid at 20 degrees centigrade because these triglycerides contain high proportion of unsaturated short chain fatty acids. Oils are generally plant origin. Fats are solid at room temperature because these triglycerides contain saturated long chain fatty acids and they are of animal origin. Triacylglycerol and fats, oils and fats, they contain triacylglycerol. This triacylglycerol in our body can be hydrolyzed by enzyme lipase, which belongs to hydrolase class. On hydrolysis of triacylglycerol by lipase, you will get glycerol and 3 fatty acid molecules. Coming to rancidity of fat. The term rancidity refers to the appearance of an unpleasant smell and taste for fats and oils. Just we have discussed at the time of polyunsaturated fatty acid. There are 3 types of rancidity: hydrolytic rancidity, oxidative rancidity, and rancidity due to repeated heating. Partial oxidation of unsaturated fatty acid leads to formation of epoxides and peroxides by enzyme peroxidase and free radicals. To understand this, see below I have given example of unsaturated fatty acid where I have shown a double bond there. Now this enzyme peroxidase or free radicals will break this fatty acid molecule into 2 parts at double bond position. Due to this breakdown, various epoxides and peroxides are formed from these fatty acids. Now, if the same process occurs in the biomembrane, that is cell membrane, it leads to death of the cell. Just now we have studied that cell membrane is made up of phospholipid. At the second position of phospholipid, polyunsaturated fatty acid is present. If that polyunsaturated fatty acid is broken down by oxidative rancidity or by the enzyme peroxidases or free radicals, then the cell damage will occur and the cell may die. Therefore, polyunsaturated fatty acids are good to maintain the liquidity or fluidity of cell membrane, but at the same time they are also liable for damage by the enzyme peroxidases and free radicals. Oxidative rancidity. Many natural fats and oils contain antioxidants, example vitamin E, which prevent occurrence of oxidative rancidity. Polyunsaturated fatty acids are more easily oxidized due to presence of more double bonds, just we have studied. So if we want to store vegetable oils contains triglycerides with polyunsaturated fatty acids. So if you want to store or if you want to increase the shelf life of vegetable oils, then you have to add antioxidants to that oil like vitamin E, which prevent the action of free radicals on the triglycerides or polyunsaturated fatty acids. Next, rancidity due to repeated heating. Repeated heating of oils would lead to formation of polymerization of hydrocarbons. These will impart unpleasant taste and color to the oil. coconut oil can have medium chain saturated fatty acid will withstand such polymerization. So this is seen when the same oil is repeatedly used for frying. So in that purpose they have told that coconut oil will withstand, means it does not show rancidity easily due to repeated heating. So it is resistant to rancidity due to heating. Physiological role of triacylglycerol. They are stored fuels. They are stored in our adipose tissue. They are present in our below the skin as a subcutaneous fat and protects our body from heat and cold. Padding effect means this triacylglycerol present around the internal organs of our body like liver, kidney, and they protect these organs from external injury. Triacylglycerol contains essential fatty acid, means polyunsaturated fatty acid. So they supply essential fatty acid to the body on breakdown. Triacylglycerol also supply fat soluble vitamins. They are present as a structural component. They act as an insulator. In our body, the nerves are covered with fats, so that when action potential, these nerves, there is a network of nerves present in our body. These nerves will cross each other at various places. Therefore, action potential, which is nothing but it is a flow of current, will not transfer from one nerve to another nerve due to presence of this insulation. Triacylglycerol also helps in the transport of lipids in the blood. Clinical importance of triglyceride. Excess deposition of triglycerides in the adipose tissue increases the weight, leading to obesity. Deposition of cholesterol in various arteries leads to atherosclerosis, which is seen in obesity. Also, when the person have obesity or his weight is increased due to deposition of triacylglycerol, such person have more chances of diabetes mellitus. Excess deposition of triacylglycerol in the liver will damage the liver and is called as fatty liver. So these are the diseases related to triacylglycerol. Next lipid is cholesterol. Average Indian diet contains 400 mg of cholesterol, but our body, mainly liver, synthesizes 1000 mg of cholesterol daily. Diet rich in cholesterol are yogurt, ghee, butter, cream, real meat, liver, etc. In the body, cholesterol is transported in two forms, LDL cholesterol and HDL cholesterol. LDL cholesterol will transport the cholesterol from liver to peripheral tissue, that is in the arteries for deposition. And HDL cholesterol will transport the cholesterol from periphery to the liver for excretion. Therefore, LDL cholesterol is called as bad cholesterol because after deposition of this cholesterol in the arteries leads to a disease called as atherosclerosis. And HDL cholesterol is called as good cholesterol because it transfers the deposited cholesterol from artery to the liver for excretion out of body. Saturated fatty acid increases and polyunsaturated fatty acid decreases the cholesterol level. Here it is wrong. Increase in the cholesterol increases the risk of atherosclerosis, particularly coronary atherosclerosis, which is responsible for heart attack. So this is the diagrammatic representation of cholesterol. On the left side I have shown you free cholesterol. On the right side I have shown that at third position OH group is present. If that OH group is replaced by fatty acid, so it is called as cholesterol ester. Now if this fatty acid is saturated fatty acid, then it is deposited in the arteries. If that fatty acid is polyunsaturated fatty acid, then it is taken up by HDL and excreted through the bile outside the body. Almost all cells of the body synthesizes cholesterol. About 140 gram of cholesterol is available, and rough distribution of the cholesterol is given here. Cholesterol is present in cell membrane because of its non-linear structure. It cannot fit compactly in the cell membrane, therefore it also helps in increasing the fluidity of the cell membrane. Cholesterol also act as a insulator by surrounding the nerves. Bile acids and bile salts are synthesized from cholesterol. These are important for digestion and absorption of fats. Many steroid hormones like glucocorticoid, mineralocorticoid, testosterone, estrogens are synthesized from cholesterol. Vitamin D is synthesized from cholesterol in the skin on exposure to sunlight. OH group of cholesterol is esterified to fatty acid to form cholesterol ester, which I have shown in the figure. Now clinical significance: increase in the cholesterol level of the blood leads to process of atherosclerosis, which leads to a process called as myocardial infarction or heart attack. If the same process occurs in the brain vessels, they leads to cerebrovascular accidents. Abnormality in the cholesterol metabolism also leads to diabetes mellitus. Next lipid is phospholipid. As I have told you, it contains glycerol, fatty acid, phospholipid and nitrogen base. This is the structure of phosphatidylcholine or lecithin, where nitrogen base is choline. These phospholipids are found in egg, fish, soybean and dairy product. They perform various functions in the body, like they form cell membrane. They are also required for lipoprotein formation. They play important role in functioning of brain. Phospholipid helps in the digestion and absorption of lipids. Lecithin, all of us know it acts as a lung surfactant. This is the cell membrane formation. Phospholipid forms micelles in the alimentary canal, which are required for absorption of fats. Phospholipid are also required for synthesis of lipoproteins, which are required for transport of lipids in the blood. Coming to the lung surfactant, phosphatidylcholine, it decreases the surface tension of the aqueous layer of the lung and prevent the collapse of lung alveoli. It is produced by epithelial cell. Constituent of lung surfactant are: main constituent is diapalmitoyl lecithin, phosphatidylglycerol, cholesterol, protein A, B and C. Coming to the clinical importance of lung surfactant, during fetal life, the lung synthesizes sphingomyelin before 28 weeks of gestation, but as the fetus matures, his lungs start synthesizing lecithin. The lecithin sphingomyelin ratio of amniotic fluid is an index of lung maturity. That means if the lecithin is more, that means lung is mature. Therefore, LS ratio, that is lecithin to sphingomyelin ratio of 2 or more than 2 indicates lung maturity. Low levels of surfactant, that is in the lungs, leads to respiratory distress syndrome. In such persons, alveoli will not open easily, and therefore the neonate baby will not able to respire properly. Fat soluble vitamins. Lipids also provides us fat soluble vitamins like vitamin A, D, E and K, which will be studied in separate lectures. So this completes our importance of lipids in the diet. Thank you very much.